G'day and welcome to the sixth video on integration, and this, my friends, is one of my favorite parts of the entire course in Year 12. This one where you're going to do integration by recognition. Essentially what this means is we're actually going to try and integrate something that we technically don't know how to do by integrating something that we do know how to do. So we sort of manipulate our knowledge a little bit so that we can find out stuff that we know. Let me just jump straight into it. I use this method from a very good friend of mine, Mr. Gardner. Cheerio to him. He uses this method called DHIS, which basically means differentiate, hence integrate something similar, and that's what we're going to be doing in this exercise here. So this is useful for integrating the product of two functions because there's no product rule for anti-diff. Okay, so for example, if I'm asked to integrate this here, I've got x multiplied by sine x dx. I actually don't know how to do that, okay? But what I can do is I can integrate something similar to that, or so I can differentiate something similar to that, and then kind of work it out through magic or something else. So let's have a go. It says the hint is by first differentiating 2x cos x, because that's what we have to do first. We have to differentiate first, okay? So I'm going to differentiate 2x cos x, and I use the product rule to do that. So I get the first times the diff of the second, that's negative 2x sine x, plus the second times the diff of the first, which is just 2 cos x. Now, every time that you do this, you can actually see the thing that you want to do, want to integrate in this answer that you get here. If you can have a look here, x sine x, if I can get my pen working, just give me a minute. Righto, back in action. So this bit here, x sine x, is actually this bit here, x sine x, and that should happen every single time. When we differentiate, we should actually get something similar to what we wanted in the first place. Okay, and then what I'm going to do is I'm actually going to integrate the entire line, so both the left-hand side and the right-hand side of the function. So I'm going to integrate this. Now, when you integrate a differentiated function, you'll just get rid of the d dx. Okay, integrate a diff, you get rid of it. And then I have to integrate this entire line along here. Now, you can do them as two separate ones if you want to, or you can do one altogether. It really doesn't matter because it's the same thing when you're adding them together. So now I've got the integration of all of this plus all of this equals that. Okay, and now I'm getting close to what I actually want because I can see that this answer here is the same as what I actually want. So now I'm just going to rearrange to find out what I actually want, which is the integration of x sine x. Okay, so now I'm just going to simply get all the things that I want on one side. So this part over here, I'm going to drag that to that side. I'm going to rearrange it, and so this is going to be over here minus this part over here. Okay, hopefully you can see what I've done there, but you can pause it and have a look at it if you want to. But I've got the thing that I want on the left-hand side and everything else on the right-hand side. And now what I'm going to do is I'm just going to make the thing that I actually want, which is x sine x, be over this side. So I'm going to take out the negative 2 at the front because I can, it's a constant, just so that I can isolate the thing that I actually want. And now I can integrate this thing over the right-hand side here, because I know how to integrate a cos function. There's nothing scary or tricky about that. So I can integrate that using the rules that I know. So integrating a cos just turns into a sine. So I get this bit over here, negative 2 integration of x sine x dx equals 2x cos x minus 2 sine x. And then I just simply divide everything by negative 2 to get rid of that over there. And I end up getting the sine x is over here and the x cos x is over here. And then I've also got a random plus c on the end as well. Okay, so I've actually been able to integrate something which I don't know how to integrate just by manipulation and using something else that's similar to that, and then be able to do it as well. So it's lots of fun, this thing. Let me show you a couple of steps before I show you another example, just of the way that I go about this, because I do this every single time I do this question, and I find if I don't follow these steps precisely, then I can get very confused and not really know what I'm trying to do. I try and do too much stuff in my head and I get confused. So I've got 5 steps, and here are the 5 steps. I'll put them all up so that you can see them all. First of all, I write the diff in this form here. So like I did with the first question, I write the diff of something equals something else. Okay, and that's what I did. If we want to go back up to the top, I said the diff of something equals, and I actually do what the diff is. Okay, that's step 1. The next step is that I integrate the entire equation. So everything, like the entire left-hand side and right-hand side, and that cancels out the dx bit. Then the third thing I do is I rearrange to find the integral that I actually want. Okay, and as you can see those steps that I've done up here. So the first one was diffing this and getting the answer to that. Then integrate the whole line, so it gets rid of this d dx here. And then the third step was I rearrange to get the thing that I actually want on the left-hand side, and then everything else on the right-hand side. And then I integrate the stuff that I know, okay, which was this bit here. I integrated 2 cos x to become negative 2 sin x. And then finally, I just rearrange, or I divide by negative 2 in my case, or do whatever I need to do, and then add a plus c just to get the actual answer the way that I want it. Okay, so what I'll do is I'll make a couple of other videos with a couple of other questions like this, because it can be a little bit tricky, but once you get it, it's lots of fun. So thanks for watching, and I'll see you in the next one.